Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Semiconductor, Electronics, Materials, Devices and Simple Circuits. So in any steps, if you have any doubts, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. And also in any other chapter of physics, if you have more difficulty, then please write the name of that chapter also in the comments section, so that we can give more priority on it and solve more and more questions on that chapter. Um, Also, some important homework questions on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that the emitter base junction of a transistor is dash biased, while the collector base junction is dash biased. So we know that the emitter base junction is forward biased. Emitter base junction is forward biased, and collector base junction is reverse biased. Collector base junction is reverse biased in a transistor. So emitter base is forward biased and collector base is reverse biased. So it is option 4 is the correct answer. Then here it is told in a forward biased PN junction diode, the uh, potential barrier in the depletion region is of the form. So in a forward biased PN junction diode, this is the P side, this is the N side. So in a forward bias, the P side is connected to the positive terminal of the voltage source, and the N side is connected to the negative terminal of the voltage source. So it means, so the in the depletion region we have a reverse voltage. A reverse voltage is formed in the depletion region. A reverse voltage is formed in the depletion region. The depletion region. So it means here the P side is having slightly negative voltage, and so the P side is having negative potential with respect to the N side. So it means option 2 is the correct answer. And here it is told identify the property which is not characteristic for a semiconductor. At very low temperatures, it will behave as an insulator only, since at T equal at very low temperatures, uh, the the valence band is fully filled and the conduction band is empty. So it means there is no free charge carriers. There is no free charge carriers whi- which are available for electrical conduction. So it is behaving as an insulator only at very low temperatures. And at high temperatures, we will have two types of charge carriers. Two types of charge carriers we will have. One is the free electrons, and the other one is the holes. Free electrons and holes. The and then the charge carriers are electrons and holes in the valence band at high temperatures. No, it is wrong. Since why the at high temperatures we have um, free electrons in the conduction band and holes in the valence band, which are available for conduction. And the semiconductor is obviously electrically neutral. So it means only the statement in the option 3 is not a property of a semiconductor. So option 3 is the correct answer. Then it is told if the forward voltage in a diode is increased, the width of the depletion region. So if the forward voltage increases, then the width of the depletion region width of depletion region that decreases. So, and if forward voltage decreases, then the width of the depletion region will increase. So they are inversely proportional. So option 2 will be the correct answer. Then here it is told, identify the logic operation performed by the circuit given below. So here simply it is A naught. Here we can say here actually here this is A naught and this is B naught, and here it is a NOR gate. So it will be A naught or B naught and whole naught. So A naught or B naught whole naught, A naught or B naught whole naught if we do, then we can apply the De Morgan's law. De Morgan's law we can apply. De Morgan's law states that A or B whole naught is A naught and B naught. So it will be A double naught and B double naught. So double naught means A only. So it will be A and B. So it is acting as an AND gate. So option 2 is the correct answer. And here it is told, in a transistor, the collector current is always less than the emitter current because it will be option 2, since a few electrons are lost in the base and only remaining. Here the transistor is somewhat like this. We have the emitter, base and collector. So a few electrons are lost in the base and only remaining ones reach the collector. So the uh, collector current is always less than the emitter current. So option 2 is the correct answer. Then here it is told, in to a germanium crystal, equal number of aluminum atoms and indium atoms are added, then it will become, okay. So we know that a- aluminum atoms and indium atoms, these are called the p-type atoms. P-type atoms, or they are the acceptor atoms. They are the acceptor atoms. Since they are since they are trivalent. Since they are trivalent, it means their valency is 3. They are trivalent atoms. So it means the if aluminum and indium atoms are added, then the germanium crystal will convert into the germinal crystal will convert into a p-type semiconductor, p-type extrinsic semiconductor. When no atoms are added, no acceptor atoms are added, then it will be an intrinsic semiconductor. And when these acceptor atoms are added, then it will convert to a p-type extrinsic semiconductor. Since why, now here we will have some excess of holes, and so it means here the number of holes will be much higher than the number of free electrons. The number of holes will be much more than the number of free electrons here. So it means option 3 will be the correct answer. Then here it is told, the truth table below is 4. Now here we see it is acting as a NAND gate. Since why, here is we see and B, A and B if we do, then 0 and 0, that is, if I tell if y equals to A and B, then if and B, if A and B they are 0 and 0, then y will be equal to 0 only. And if A and B are 0 and 1, then y will be 1, since 0 and 1 is 1, and 1 and 0 also will be 1, and 1 and 1 will be 1. So here it is here it, okay, so no, 0 or 1, no, 0 and 1, that is 0, 1 and 0, that is 0. So simply the output is the opposite of this. So it is the not of this thing. So if we take, okay, this as y naught, so 0 naught, that will be 1. So it means that y is acting as a, it is a NAND gate. It is a NAND gate. So it is the truth table for NAND gate. So option 1 is the correct answer. Then it is told in a reverse bias diode, when the applied voltage increases, by 1 volt, the current I is found to change by 0.5 microampere. Then the reverse bias resistance of the diode is. So the reverse bias resistance of the diode, that will be given as change in voltage by change in applied voltage by change in current, delta V by delta I, which is the resistance, the reverse bias resistance. So it will be 1 volt divided by 0.5 into 10 power minus 6 ampere, and volt by ampere, that is equal to ohm. So that will be 1 by, this will be 1 by 2 into 10 power minus 6, this will be ohm. So this will be 2 into 10 power 6 ohm. So it means that option 3 is the correct answer. And here it is told minority carriers in a p-type semiconductor are, minority carriers in a p-type semiconductor are. So in a p-type semiconductor, we have excess of holes. So it means the number of holes is much more than the number of free electrons. So it means so here the free electrons are the minority carriers. So the free electrons are minority charge carriers here, minority charge carriers, and the holes, are the majority charge carriers. Holes are the majority charge carriers. So it means option 2 is the correct answer. So then here it is told when a PN junction diode is in forward bias, which type of charge carriers flows in the connective wires? So when a PN junction diode if you have, then it is connected in a forward bias. It means the P side is connected to the positive terminal of the voltage source, and the N side is connected to the negative terminal of the voltage source. Then it means the charge carriers, means the current will flow from P to N, and the free electrons will flow in the opposite direction, means from N to P, in the opposite direction it will flow. So it means the charge carriers flowing in the connective wires, they in the connective wires, charge carriers in the connective wires, they are free electrons. So option C is the correct answer. So here in the PN junction diode, here holes are also the charge carriers and free electrons also the charge carriers. But the type of charge carriers which are flowing in the connective wire, that should be only free electrons. Since why holes cannot move through the connective wires. Okay. And here it is told the energy gap, it means it is also called the energy band gap, of the LED, that is equals to 2.4 electron volt. Then when the LED is switched on, the momentum of the emitted photons will be. So here we know that the energy of the emitted photons, that is hc by lambda, that should be equal to the energy band gap, and h by lambda, that will be equal to the p, which is the momentum of the emitted photons, that will be equal to the energy gap by C. So that will be equal to the energy gap, which is 2.4 into 1.6 into 10 power minus 19 joule. Since 1 electron volt we know that is equals to 1.6 into 10 power minus 19 joule, and that divided by the C, which is 3 into 10 power 8 second, 10 power 8 meter per second. So 3 8s are 24. So then 16 8s are, that is 128. So it will be 1.28 into 10 power minus 27 kg meter per second. So option C is the correct answer. Then here it is told that the truth table for the given circuit is. So here we can see that this one, this will be A, this is A, and from here again, okay, B is there. So this is OR gate with a NOT, so it is a NOR gate. NOR gate, it means that here the output will be A or B whole NOT, A or B whole NOT. And then here again we have a NAND gate, a NAND gate, NAND gate. So here we have the output, let's say that is X. Now this is A, this is A, and this is B. So here we have an AND gate. Here we have AND gate. So X equals to A and B. X equals to A and B. And this is a NAND gate. So the output, let's say here, this one is equal to, suppose this one is X1, suppose. This one is X2, suppose. So here the output will be a NAND gate. So it will be X1 and X2 whole NOT. So Y, so it means that Y actually that is equals to X1 and X2 whole NOT, where X1 is, so it is A plus B NOT, A plus A or B whole NOT. So we are saying OR means plus and AND means dot. So we are signifying AND with a dot and OR with a plus. So A or B whole NOT, and NOT we are saying by using a bar. We give a bar means NOT, we are saying. Okay. So A or B whole NOT, this is X1, and X2 is A and B, A and B, and again it's whole NOT. Now here we can apply the De Morgan's law. So according to the De Morgan's law we have, so according to the De Morgan's law, we know that suppose let's say we have C and B whole NOT, then it is given as C naught or B naught, and C or B whole NOT, that is equals to C naught and B naught. So here AND will change into OR and OR will change into AND. Okay, this is the De Morgan's law. Now therefore Y, that can be written as, this will be, this if I take it as C, so C, so it means X1 and X2 whole NOT, X1 and X2 whole NOT. So that can be written as X1 naught or X2 naught. So that will be X1 naught, that is A or B whole NOT, it's not again. Then or X2 which is A and B whole NOT, B whole NOT. So that is equals to A or B. Okay. So therefore Y1, so therefore Y I can say that is equals to A or B, since double naught means that will get cancelled, and plus that will be A naught or B naught. Okay, so now this means this will be A or A naught, A or A naught plus B or B naught. B or B naught is therefore y is equals to A or A naught plus B or B naught. So therefore, so it is 1 1 1 0 0 1 and 0 0. Okay. So therefore, the truth table, we have to draw the truth table. So now A or A naught means 0 or 1. That will be 0 or 1. That will be 1. And 1 or 0, that will be 1. So it will be always 1. And plus B or B naught. Plus B or B naught, that will be also 1. So 1 or 1, that will be always 1. So the output will be 1 always. Output is 1 always for any values of A and B. For any values of A and B. Therefore, output is always 1. So it means A or B, if it is 1 or 1, then also Y will be 1. If it is 1 or 0, then also it will be 1. 0 and 1, that then also it will be 1. If 0 and 0, that will be also 1. So the output is always 1. So option A is the correct answer. Then here it is told a full wave rectifier. Full wave rectifier, it means here two PN junction diodes are being used and a center tapped transformer is also okay. Okay. So it is used. Okay. So two PN junction diodes are used. So it means the rule is in a full wave rectifier, we have, so if the input is like this, then the output, if the input is this, and then the output will be this. Output will be this. So it is a full wave rectifier. So in a full wave rectifier, when okay, the diode D1 conducts for half of the cycle, and the diode D2 conducts for the remaining half of the cycle. Conducts for the remaining half cycle. So it means in every cycle the same thing will happen. Every cycle the same thing will happen. So it means that in the first half, let's say here diode D1 will conduct, and in the next half D2 will conduct, and in the third half again D1 will conduct. Next, in the next half again D2 will conduct. So it means it will so if the frequency of the alternating voltage, if the frequency of the AC voltage, if it is 50 hertz, it means we have 50 cycles per second. 50 cycles will be there in 1 second. So it means that in 50 cycles, in each cycle, in the first half D1 will conduct, and in the next half D2 will conduct. So in these 50 cycles, so I can say in this 1 second, in 1 second, or in every second, in 1 second, the diode D1 also will conduct 50 times, and diode D2 also will conduct 50 times. So it means that option B is the correct answer. So hope all of you have understood the solutions of these questions. based on the previous year KCET exam on the on the chapter Semiconductor, Electronics, Materials, Devices, and Simple Circuits. Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Um, mm, Also, please install our Sapience Education application, where we shall upload some important homework questions based on the previous year KCET exam, which shall be obviously helpful for your exam. So, thank you everyone. Bye.